Alright, so we're going to solve another center of mass problem. Today we're looking at a piece, somewhat unusual board piece, which is missing a hole. So the story is that we have an 8 by 4 centimeter board with original mass of 300 grams, and there's a 3 centimeter diameter hole that's drilled as shown, so it's centered vertically and 1 centimeter from the right side. Let's find the location of the new center of mass. These types of problems are kind of tricky, and I think the approach we want to take is to go back to our original formula where we have x center of mass is equal to individual pieces times their centers of mass. So x1, m1, x2, m2, all over this total of mass. And it seems like we only have one piece here, but it might help if we remember there used to be another piece. So if we imagine that this hole is still there with us, that's going to be the trick to solving this. 3 centimeters across makes it a radius of 1.5 centimeters is the radius. So imagine that that piece and this board piece are the two, 1 and 2, in our story down here. When we put these both together, then our center of mass would be exactly where we think it would be, in the center of the board. So let's call this side over here x is 0, and then move to the right as our positive axis. So that means the combined pieces of the board with the hole and the piece, let's call it the plug, that would fill up that hole, that's going to put us at 4 centimeters exactly referenced from the left. Okay, and what we've got now is the distance to our plug piece. So that's the center of the plug. So that would be 4 centimeters along the board plus another 1.5 centimeters. That's the distance to the plug center of mass. And we have to multiply it by the plug mass. Then x2 is now the center of mass of the board alone, and it would be somewhere shifted to the left. So that is the actual unknown in the story, and that's exactly what we're supposed to find here. So I'm going to call it the board, and that board implies that we're missing the plug. And I multiply that by the mass of the board without the plug. Divide by both mass of the plug plus the mass of the board. And we know that these two together give us 300. Scooch down a little. So we have to assume the density is uniform. I'm not going to actually find the mass per volume density. I'm going to stick with a mass per area density because I don't really care about the thickness of that board. So I'm going to take 300 grams and divide it by the original full dimensions here. 8 and 4 gives me 32 centimeters. That's the density of the board before I do any drilling. Once I take out the plug, I would have the mass of the plug over pi times 1.5 centimeters squared. So I'm just saying that the density of these pieces is uniform. This tells me that the mass of the plug is going to be 66 grams, and the mass of the board is down to 234 grams. As I add these together, of course, I'll get 300 grams, and that quantity is going to go down in the denominator. This quantity is going to go into the mass of the plug, right here, mass of the board. So as I come back to my definition of center of mass, and I can now solve for the center of mass board. I'm going to get 3.6 centimeters. Pretty small number. When you come back and take a look here, I know to get to that original we had 4 centimeters, and now to get to here only 3.6 centimeters. Pretty small change considering the size of that hole, but that's what the equations are going to tell me. So that's how you'd find a center of mass of something that's missing of another uniform object.